Hi everyone, welcome to Infinity Learn by C. Chaitanya. In today's session, we will discuss a very important concept of grade 9, that is histogram, and this is a part of statistics, right? So this is the graphical representation of data. If the data is given in the form of class interval and the respective frequencies. So we will see how to draw the histogram for the different type of data. Okay, so let's proceed. Yeah, so before moving ahead, we have an announcement. Okay, that is for score. This is a scholarship exam for admissions in any branches of Sri Chaitanya, right? So how will register for the score? Then yeah, you will get the link for the registration in the description. Simply press on the link, you will get a form, fill the form, then yeah, you will be registered. You will get a date. Simply you have to appear for the exam on that respective date, right? So what is the benefit of this score? So these are the benefits. You will get the educational allowances like book, notebook and many things, videos, right? Then study setup and laptop like study table, laptops for your online education, also types. Then up to 100% scholarship. So this scholarship will depend on your performance in the examination, right? So if your performance is good, then you will get 100% scholarship, means you don't have to pay any fee for the admission, right? Okay. So let's start the session. What is histogram? Histogram is a graphical representation for the data if it is given in the form of class interval and their respective frequencies, right? So what are the two important things that we should keep in our mind while drawing the histogram? So what is the first thing, guys? So let me tell you what is class interval and frequency, right? Suppose data is given of this form. Suppose this is our data. See. Right, this is our data. This is class interval and this is frequency Fi. Suppose the class intervals are 0 to 10, 10 to 20, 20 to 30, 30 to 40, and this is respective frequencies like 2, 5, 3, 1. So we can draw the graphical representation of this data, and that is called as histogram, right? So while drawing the histogram, you have to keep two things in your mind. The first thing is class interval should be in exclusive form. It should be in exclusive form. If it is not in exclusive form, you have to convert it into exclusive form, right? And the second important thing is width of class interval should be uniform, means class size should be uniform, right? If these two conditions holds true, then we can draw the histogram. If any one condition do not holds true, then first of all we will convert the given class interval in the exclusive form, or accordingly if it is not uniform class size, then we will do some changes, right? So we will cover all these type of questions in today's class. Let us see what is class size or class width. So here we have class interval 0 to 10, 10 to 20, 20 to 30 and 30 to 40. So this 0 is called as lower limit, that is represented by L, and this 10 is called as upper limit, right? If you take the difference of lower limit and upper limit, then you will get class size, and class size is represented by H, and that is also called as class width, which is 10 minus 0 is 10, right? And this is also called as class width. So the class size for every class interval should be same, then it is uniform. If it is different, then it will not be uniform, right? So 10, 10, 10, 10, 10. Yes, class size is uniform, right? Exclusive form. What is exclusive form? Exclusive form means, let us see the first class interval, that is the upper limit is 10. Then 10 should be the lower limit of second class interval. If 10 is the lower limit of second class interval, then it will be in exclusive form. Otherwise, it will be in inclusive form. Suppose we have 1 to 9, right? Then 10 to 18. So here, what is the upper limit of first class interval? 9, and the lower limit of consecutive class interval is not 9, which is 10. So this is inclusive form. This is inclusive form. So if the class interval is of this type, then we will convert this inclusive form into exclusive form by just calculating the adjusting factor, and we will adjust that factor. Simply you have to subtract that factor in the lower limit and add the factor in the upper limit, right? So we'll do all type of questions. So let's start with the question part, guys. Here we have first question. Distribution weight in kg of 100 people are given below. Construct the histogram for the above data. So first of all, check two things. It should be in exclusive form. 45, 45, 50, 50. Yes, this is in exclusive form, right? So this will be 55 to 60, and this will be, please, there is a change, 60 to 65, then 65 to 70. This is in exclusive form. Certain misprints is there, right? Now class size. What is the class size? 5, 5, 5, 5, 5, 5, 5 uniform. So directly we can draw the histogram, right? So for that we represent the class interval on the x-axis and frequency on the y-axis, right? So let's say this is 0. So between 0 and 40 there is no observation. So I will start from 40, then 45. So basically this gap represent 1 centimeter, right? So what is the scaling? So 5 unit is equal to 1 centimeter on the x-axis. 5 unit is equal to 1 centimeter for x-axis. So this scaling is important, right? 45 to 50, then 50 to 60, 60 to 65. Sorry, 55 to 60, 60 to 65 and 65 to 70. Now frequencies. So for frequencies I will use the scaling factor. So what are the frequencies? 13, 25. Yeah, same thing for y-axis. Same thing for y-axis, right? So 1 centimeter is equal to 5 unit, 10 and 15. Simply draw the bar. Bar is a rectangle, right? So 40 to 45, the frequency is 13. So this is 13. So we will do like this, right? So this is 13, 40 to 45, right? Then 45 to 50, the frequency is 25. So 20, and here we have 25, right? So 25. Then 50 to 55, frequency is 30. So let us show this is 30. Right, so we have 30 over here. Now 55 to 60, 55 to 60 it is 15, so this is 15. Then 60 to 65 it is 12, so this will be 12, right? Then 65 to 70 this is 5. Okay, so the width of every class should be same. Width of every class should be same. Height varies according to the frequency. Now there is no information between 0 to 40, so we will use the king symbol. Which symbol? King symbol over here. So what is king symbol? This symbol is called as king symbol, like this, right? So draw the king symbol simply, right? This is the king symbol, right? Because we don't have any, this king symbol denote that there is no information between 0 to 40. So this is the histogram for this data, right? So hopefully this is clear to everyone. We can directly draw the histogram because two conditions are satisfied over here. What are the two conditions? The class size should be same, that is uniform, and it should be in exclusive form. Let's take one more example. Draw the histogram to represent this data. See guys, so check the conditions. First of all, check whether it is in exclusive form or in inclusive form. Upper limit is 17 and the lower limit of next class interval is 18. So this is not in exclusive form. So we'll convert into exclusive form. This is in inclusive form. How will do this? Simply find the difference of these two. Either you can find the difference of 17, 18, 25, 26, 33, 34, 41, 42, 49, 50. So simply you have to find the difference, that is gap. So 18 minus 17 is 1. So we'll find the adjusting factor, right? We'll find the adjusting factor. So how will find the adjusting factor? So that is 18 minus 17, then divide by 2. Why divide by 2? Because we are adjusting this difference into two places, right? In the lower limit as well as in the upper limit. So you will get 1 by 2, which is 0.5. Now how will adjust this? So for that you have to subtract this adjusting factor in the lower limit. So L stand for lower limit. So L minus 0.5 for every class interval. And in the upper limit you have to add this adjusting factor. Means for every lower limit you have to subtract. So 10 minus 0.5 is 9.5 and 17 plus 0.5 is 17.5. So this will be 9.5 to 17.5. Now subtract this 0.5, so you will get 17.5 and 25.5. Now you can see it become in exclusive form, right? So form the new class interval. So this will be the new class interval. Now the class interval is in exclusive form. Now again guys, class interval is given, frequency is given, you can draw the histogram, right? How will do this? So 9.5 to 17.5, then 17.5 to 25.5, then 25.5 to 33.5, then 30, no not 30, this will be 35.5. Yes, please correct this. Let me check. Yes, ठीक है. So this will be 33.5, right? Then 41.5, and accordingly it will be 49.5, then 57.5, right? Now the frequencies, so let's say this is 100, so 1 centimeter is equal to 100 unit on the y-axis, right? Then 200, 300, 400, 500, 600, 700, 800, 900 and 1000, right? Now you can draw the histogram. So for this it is 300. So this is 300, right? For the second one it is 980. So it will be 980 like this, right? Then 740. So it will be here something here. So 740. Then 580. So this will be 580, right? Then 260. So 260 will be here. Then 140. So this will be 140, right? And now draw the king symbol. Okay, between 0 and 9.5, because there is no data between 0 and 9.5. What is the scaling on y-axis? On y-axis, 100 unit is equal to 1 centimeter. On x-axis, what is the gap guys? 9.5. No. So this is 0.95. This is 9.5 and 19.5. No? So what is the gap? So this is 17.5. No? So the gap is 8, right? So 8 unit is equal to 1 centimeter, right? So in this case guys, the class interval was not in exclusive form. First of all, we will convert in exclusive form. I will do this, find the adjusting factor, subtract the adjusting factor in the lower limit and add the adjusting factor in the upper limit. So what can be the third variation? So yeah, we have a question over here. A survey was done to find out how many kids of different ages were playing in a park, and here what they found. So age group of 1 to 2, how many children are there? 5. And yeah, the data is given. Simply we have to draw the histogram. So this is in exclusive form 2, 2, 3, 3, 5, 5, 7, 7. But let us find the class size. So 2 minus 1 is 1. So the class size is 1. Here the class size is 1. 5 minus 3 is 2. 7 minus 5 is 2. 10 minus 7 is 3. 15 minus 10 is 5. And here we have 2. So the class size is not same. Means class width is not uniform. So since the class width is not uniform, we cannot change the class interval, but yes, we have to adjust the frequency. So what we will do, if the class size is not uniform, then we have to adjust the frequency. Means we will find the adjusted frequency, and there is a formula to find the adjusted frequency. So adjusted frequency will be equal to minimum class size upon class size of that class interval, class size into frequency, that is f. So we use this formula. Let us find the adjusting class frequency, that is new class frequency for the first class interval. So what we will do, we will find adjusted class frequency, that is af. So what is the minimum class size is 1. So 1 upon, what is the class size of this class interval? 1. And what is the frequency? 5. So 1 by 1 into 5 is 5. Again let us find for this one. So again guys, minimum is 1 and the frequency of class size is 1, sorry, class size is 1 and the frequency is 3, so 1 by 1 into 3, that is 3. Let us find for this. What is the minimum class size? 1. What is the class size of this class interval? 2 into 6, so that is 3. Means if the class size of the class interval is same as the minimum class size, then the frequency and the adjusted frequency will be same, right? And for the remaining one it will be different. So for that what will be? So again guys, 1 by 2 into 12, that is 6, so it will be 6, right? And for that it will be, so here we have 1 and the given is 3 into 9. So once you solve this, so you will get 3. And for this class interval we have 1 by 5 into 10, that is 2. And for this we have 1 by 2 into 4, that is again 2. So this is the new frequency. Now what we will do guys, we will forget this frequency, we will focus on these two. So this is the class interval that will be represented on the x-axis, and yes, this is the adjusted frequency. So we use the adjusted frequency in this case to draw the histogram, right? So what are the adjusted frequency? 5, 3, 3, 6, 5, 3, 3, 6, then 3, 2, 2, 3, 2, 2. So let us draw the histogram. So for that, so this is our y-axis and this is x-axis. What are the class interval? 1 say 2. So this is 0 to 1, then 1 to 2, then 2 to 3, then 3 to 4 till 17, right? Similarly till 17, right? Okay. Then we have frequencies, so we will use adjusting frequencies, right? So what is the adjusting frequencies? So for that, for y-axis we use 1 centimeter is equal to 1 unit, and we use the same scaling on the x-axis also, right? So 0 to 1 there is no information, so we use king symbol over here. 1 say 2, the adjusting frequency is 5, so 1, 2, 3, 4, 5, 6. So 1 to 2, this is 5, like this. Okay. Now 2 to 3 we have 3. So 2 to 3 we have 3. Now 3 to 5, while drawing the rectangle for 3 to 5, the width will be 2. So we will take this entire width, right? 3 to 5, and the height is this one, which is 3, right? So we use this one. Then 5 to 7, 5 to 7 we have 6, 5 to 7 we have 6, no? So 5, 6, this is 6, right? Now 7 to 10, so let's say we have 10 over here, so 7, 8, 9, 10, 8, 9, 10, for 7 to 10 we have 3. So similarly you have to complete this. 10 to 15 we have 2, so 10 to 15 we have 2, let's say this is 15, and 15 to 17 we have again 2. But in this case the class width should be 5, in this case the class width should be 2, right? So this is our respective diagram. Here there are certain glitches, so you have to do accordingly, right? The class width will be more in comparison to given one because we have not space, right guys? So let us find the area of one rectangle. No? Let us find the area of this rectangle. So what is the width? 2. What is this length? 6. So 2 into 6, that is 12. And what is the 12 for this class interval 5 to 7? For 5 to 7, 12 is the frequency. So this is a very important thing guys. Area of every rectangle represent the frequency of given class interval, right? And that's why we use histogram for finding the mode of the data, right? So this is the graphical approach to find the mode of the data. So what does area of every rectangle represent? Area of every rectangle represent the frequency of that class, and yes, histogram is used to find the mode of any observation graphically. Okay, so this is very important topic. In your exam you will get one question from this topic. So yes, watch the session, try to solve the questions from your book. If you face any difficulty or any doubt, then you can ask me, you can write in the comment section. And yes, if you are new on the platform, then please like the session, share it, and yes, don't forget to subscribe. Bye guys, take care. Thank you for watching.